to come to you? No, it was just a hangover. So recording and transcription started, and like I did last time, I'll put this up on my YouTube channel. You can also access it via the meeting link on Teams. One of the things we said last time when we were setting up these objects was we have used the same name. So we've passed name and set it to name, we've passed location and set it to location, and so on. We don't have to call them the same things. They can be changed. It's entirely up to us. And the other thing I pointed out last time was, very kindly, this is VS Code. You can see that in the init, the colours are changing. So they've gone light blue here because we've referenced them. This one's still kind of darker blue because we haven't yet set it up as part of our initialization. But when I do, that changes and becomes light blue. So it's just a nice wee aide-memoire to remind us. The other thing that it reminds us is the red underline, just like you'd get in Word or wherever if you misspell something, because as ever, I've forgotten my colon. So one thing I'm really good at is forgetting my colon. So that's our initialization, and we can now set up variables or instances of objects as a variable. So we can set up player one. Or we can give them actual names. So our first player is Bickrant. And he becomes a suspect. Bickrant looks very much like a Miss Scarlet to me. And I'm pretty sure that he'd be in the ballroom. Nikita is also a suspect. Clearly a professor if I've ever seen one. And Nikita is going to be haunting the library. And our third player, Marissa, definitely a woman of the cloth. She's going to be Reverend. And will be in the hall. All happy with that?
You forgot to put the brackets near the hall, if you can see.
Okay, so VS Code has told me that. It's put a yellow wavy underline this time. And it's told me I've passed the wrong type of object. That could have been the right type of object, actually. I could previously have set up a variable called hall. And rather than pass the text, I could easily have passed a variable. So it doesn't have to be set up using these values. They can be set up using variables. So in this case, I'll set up the variable hall to have the text hall, and it'll work in exactly the same way. The yellow underscore has now gone, and it's accepted that as a variable to be passed into the initialization. So we've got the class, we've instantiated some variables to go along with that. We'd now kind of like to put some working around that to actually allow it to do stuff. So the first thing they probably want to do is have a function that says, who are you? and that's past the object. And that's going to be very simple. I'm just going to print out whatever you've passed. Title. And their name. Still the red underlines. What's that unhappy about this time?
I think we have to change the print to return.
We have to change the print to return.
Yes,
Why is that?
if we want to leave the self-title and self-name as they're saying right now. If not,
No,
we just in the brackets and that's it.
no, we don't have to return anything. No. What were you saying about brackets there, sorry?
I was just saying that if we don't change it to return, let's just put the self-title and self-name into the brackets and that's it.
All we've done here is we've forgotten to put brackets around the function name. Same as I always do. We don't have to return anything because what we're doing with this piece of code is simply printing out the title and the name. We don't have to return anything because we're not changing anything or calculating or working anything out. We're simply printing out who you are. So I can simply say, Vikrant, who are you? Not forgetting the brackets. And if I run this text, after I've saved it, and preferably don't save it as a text file, which, you know, it gets very upset about. And it says ballroom Scarlet. So we have an issue. What's happening there? And I don't just mean the fact that I misspelled Scarlet. Why has it swapped the location and the title?
What would happen if you change the title and the name in the init function?
I don't know, but before I change that, let's actually just print out the third one and see what it does. So let's print out self.location. Doesn't seem happy about that at all. It's gone all grey and yucky. Suspect object has no attribute location, so why not? Go through the code line by line. If you need to, say it out loud. Class suspect, def init, self, title, name, location, self.title becomes title, self.name becomes name, self.title, what? So at some point I've put in self.title and it's overwritten the title with the location. When what I should have put in was self.location. So you need to be really careful. There are 18 people in this meeting. Not one of you put up your hand and said, hang on, what are you doing there? Thank you, Marissa, for getting in there. So if we do it now, it's now closer to what we want, Miss Scarlet Ballroom. But this function was only about saying who you are, but we'll write another one to say, where are you? We'll define another function that says, where are you? Pass it the variable and print, not forgetting the brackets this time, self dot location. So as well as saying Vikrant, who are you? I can now say Vikrant. And when I hit the dot, we've now got a new function. Where are you? It says Miss Scarlet Ballroom. We probably shouldn't leave it like that. We should probably say something like, I'm in the, and I am, just to make it look a bit better. So we have a couple of functions to say who you are and where you are, and we can apply these to any of these variables. We can do the same for Nikita. Nikita, where are you? I'm in the library. Okay, so we can start to build up our class with some information about it and give it some functionality, all contained in the class. And when we create these new variables, they take on the information and the functionality. Is everyone happy with that before we move on? Anything you don't understand about that? Thank you, Nikita, for confirming. Okay, I'm not seeing any questions anywhere and I'm not seeing any hands, so I'm assuming you're all okay with that. So we can use these functions and we can use them for anybody. Thing is, it's not a particularly easy way to set this up. By which I mean, what if it's not Vikrant, Nikita and Marissa that are playing? What if it's Summer, Care and Lauren? It wouldn't make much sense to call them Vikrant, Nikita and Marissa. We probably should have taken Jerry's original advice and just called them player 1, player 2 player 3. But even that doesn't seem quite right, because we've got 3 different variables, when actually what we've got is a set of players. Another name for that might be a list of players. So we could set up a list of all the players, and then we can start adding in our players depending on how many we have, because you don't always have to have the same number of players. So you can imagine you've got your menu system started. Player 1, give me your name, and then you assign them the information. So players, instead of player 1, you get players, and we'll append to the list a new suspect. And we can do that for each player that we have. 2, 3, 4, 5, or 6. And the nice thing about that is, whenever we go and ask, who are you or where are you, we can do it for everybody. We can say for player and players, players is this list, and we've set it up and we've added 3 players. We can say, oops, player where are you? What that will do is cycle through all the players that we've appended to this list and give us all of them using a nice wee file loop. Except I'm not quite there yet. Because I had some stuff that I was doing before, because I'd set up the variables and the variables become, so I'd use these equality signs. Players append becomes suspect. I wasn't thinking exactly how append works. You don't say a player's append becomes. Append is a function. So you say what you're going to append. This shows a couple of things. It shows that you need to be clear on what it is you're doing and where, but it also shows why you should design your solution before you start coding. Because when you change things as you go along, you get these kinds of issues. Nikita.
I just still can't visualize how it looks in the list. Is it possible to print the list out just to see how it?
Well, hopefully this time when I say go, it's printing out the first player in the ballroom, second player in the library, and the final player in the hall. But I could also add in player dot who are you? So we can go through the list, printing out each player in turn, saying who they are and where they are. So we get the first player, which we set up as Miss Scarlet in the ballroom. So it says, I am Miss Scarlet, I'm in the ballroom. Second player, I'm Professor Plum, I'm in the library. Third player, I'm the Reverend Green, I'm in the hall. Is that okay, Nikita?
Yes, indeed. Thank you.
Now, for those of you that did look up Cluedo or were listening to the explanation I gave, one of the things I said you do is you move around the board, and the board has all these different locations. And you move around the board asking things. Is the lead pipe in this location? Are you in this location? So what we need to be able to do is take each player in the list and be able to move them to a new location. Because we've got this set up as an object, that actually becomes really easy. Because each player has the same functionality, in the same way as they all can say who they are and where they are, we can also set up a new method. And remember that for objects, these functions that we're setting up are called methods. We can set up a new method that just says, change the location. Who is it you're moving? So that's the self part. And where are you going to? Some new location. So you can say self location becomes new location. Helps if you spell change correctly. And it's really simple. All we have to do is set up the new method, and then we can say players, oops, and we'll say which player it is. So player one, run the method, change location, and stick them into the kitchen. Now, before I run this, put into the chat who is going to be in the kitchen. And thank you. I've yet again forgotten my colon. Who have I just moved to the kitchen there? Go on, stick something in the chat. Tell me who's moved to the kitchen. Professor Plum. Come on, Frank. Come on, Uma. Professor Plum's the first one here. Professor Plum's the second one here. I said the first one. That can't be right, can it?
Miss Scarlett.
Miss Scarlett, the first one. I'm glad somebody said it. Frank, you should have stuck to your guns. Uma, you're quite right. Remember that these are zero-based. So this isn't suspect 1, even though it's the first one on the list, it's suspect 0. Or players 0, rather. 0, 1, and 2. All of these things are zero-based. So when we say player 1, it's actually Professor Plum. So we go through it. Scarlet in the ballroom, Plum in the library, Green in the hall, and then we change it. Scarlet's still in the ballroom, Plum is in the kitchen, and Green is in the hall. Any questions about that? Nope, all happy about it? Okay, in that case, if you're happy with that, let's move on to the next example. Because remember what we're talking about here. We're talking about polymorphism. And the idea is we can take an object and it can do different things depending on what it is. Now, this example doesn't really show that. All the players do the same things. They're all equal in that sense. So what we really need is a different example. And I am going to give you an example with shapes. So we're going to set up a class, and we'll start with a very simple shape. And our first thing that we're going to do is give our shape the one thing that it needs. A square is regular, and the only attribute that it has is the length of its side. So we can say, set up the square with its side. So we can set up square 1 as a square with a length 5. Okay, we've got our first square. And we can say the area of that square is the length times the breadth. Squares are regular, so it's 5 times 5. So the area of the square becomes its side squared. And in Python, squared is 2 asterisks. So side to the power 2. And I can prove that by printing off the area. And I'll just run that to prove it. Once I've saved it, that is. So we've saved that, we run it, and we've got 25. So far, so dull. And I suppose the first thing we're looking at is, well, why are we calculating the area out here? Every square, you use the same formula for every square. Why are we calculating it out here when what we really should be doing is calculating it as part of the object itself? We could calculate the area of this square simply by saying that. Now, the thing that we have now is how we get that out of there. So we've calculated that. And if all we're doing is printing it, if we're displaying it, we could simply print that within the calculate area, but we might not want to print it every time. We might want to use it somewhere else. We might want to use it in some other calculation. So we might want to get it out of that method. And we've got another keyword that we can use. And the keyword is return. So from this method, we are going to return that value. So now, instead of putting the calculator into the text, we've now got a method, calculate area, which says that we've also got a method, and we can set that variable with that method, and we'll get the same thing back. So it's returned the 25, we've set it to this variable, and we've printed it out. So we've got a couple of things there. We're moving on with this idea that when we're describing an object, everything we can do with it should be within the object. Why have it elsewhere? Because you might need it again, and we want to reuse code. We don't want to rethink these every time. So if you're doing something with an object, store it with the object. Let it do it on its own. We're also introducing the idea that we can send things back. So it's not just about doing stuff within the object itself. It's about doing stuff that pertain to that object, but sending it elsewhere. So say you're programming a game and you want your spaceship to go from there to there. So somebody's pressed the right hand key, and you know that in your game that means that the x-axis adds 10. So somebody presses the right key, spaceship.location.x becomes spaceship location x plus 10. You can then return that and allow that to be used to update the screen, and your spaceship will move along. That's still not polymorphism, though. And this whole lecture is about polymorphism. And the idea with polymorphism is that we can let the objects figure out what they're supposed to do on their own, depending on what they are. I'll show you what I mean. It's easier to show you what I mean than to say it. So I'm going to copy and paste. Now, always, in fact, I would always say, don't do this. Type the stuff in. As you saw earlier, it's far too easy to just copy and paste and then make a mistake and not be thinking about it. The only reason I'm copying and pasting this time is so that we can compare and contrast these two different classes so that you can see what I'm doing to them. So we've already got a square. Let's do a circle. Circles don't have sides. You define a circle by its radius, which is the value from the center point of the circle to the outside. So the center point to the line on the circumference. It's called the radius. So we can define the circle not by its side, but by its radius. So far, so good. We do have another change. The area of a circle isn't its side squared. We don't even have a side anymore. We've got a radius. And it's not the side squared. There's another part to it. So you may remember from school, the area of a circle is calculated as pi. Now, I could go at this point and import the math library. I'm not going to, just for speed. I'm just going to pretend that pi is 3.14. So it's pi r squared. Pi times the radius squared. So times the radius squared. Okay, we've now got a circle. And we can do the same sorts of things. So instead of square one, we can have circle one. that we can set up as a circle with a radius 5. We can then calculate the area of circle 1 and print that off. So let's do that. What have I missed? Oh, there we go. I missed pressing return. So a square with a side of 5 is 25, and a circle with a radius of 5 is 78.5. We okay with that so far? Anything in the arithmetic or any about squares and circles that you're not clear on before we move on? So we've done this, and it's, again, we're still in a kind of, so who cares? All we've done is define two different things in different places. Well, the magic comes slightly later. So this is where we have polymorphism. Let me set up a list. And in that list, I'm going to initialize different things. I'm going to initialize a circle. Oh, need to give it a radius, 3. We'll set up another circle. Radius 4. Let's have a square for a change. With a side of 3. Let's go back and do another circle. With a radius of 5. And we'll end up with a square with a side of 6. Okay, so we've got a list here. It's mixed, 3 circles, 2 squares, in a different order. Here's where the magic happens. We can use our same format that we did in Cluedo, which is to say we can use this for player in players. So I'm going to say for each individual shape in the list shapes, and just for once I won't forget my colon, and I can say the shape and I'm going to calculate the area. Now remember what we're doing here. We've got different types of shape, squares and circles. Each of them has different ways of calculating the area. But when we run this program, Python will figure out which is which. Helps if you actually say print it, doesn't it? We'll calculate which is which. What am I missing? What am I missing, somebody? There we go. I didn't save it. So what it's done is it's worked its way through. So a circle with a radius of 3 has got an area of 28.26. Circle 4, 50.24. A square with 3 is 9. A circle with 5 is 78.5. And a square of 6 is 36. Even though we've used the same method here. What Python's done is it's gone through the list, figured out which type of object each item is, whether it's a square or a circle. And when we've asked it to calculate the area, it's decided, well, this one's a circle, so I want to use this. And this one's a square, so I want to use this. Want to build up your set of shapes? No problem. Add on a rectangle, which has a length and a breadth. So we initialize it with a length and a breadth. And when we calculate the area for a rectangle, it's length times breadth. Don't need those brackets, I just like to put them in. Oh, I forgot to actually paste it. So we've added in a rectangle to our square and our circle, and we can now create a new rectangle with a length of 4 and a breadth of 3. And now when we go through this, our name length is not defined. No. Helps if you remember to reference the object itself. So not just length and breadth, it's self, whichever object we pass to it. And we'll try again. Sorry? Yeah. So in our output, our final one is 12, because we had a rectangle of 4 by 3. So we've added in our new shape, we've added it to our list, and our for loop, because of polymorphism, coped with it quite happily. We called it calculate area, and it just changed the area quite happily. Calculate it depending on what you do for that type of object. And as long as you give them the same name, it's quite happy to do that. Anybody got any questions? Right, so I hope that what you can see is you can now do the exercises. I've done one for you actually, I've forgotten that. So I've done the area of a rectangle. You can set up a triangle and do it the same way. And now thinking back to your menu system that you did in T1, you can add in a menu system. You can say, what kind of object do you want? And depending on the type of object, you can get what you need, whether it's a radius or a length and a breadth or whatever. You can then add them into a list and have all their areas displayed. And you can then extend that out to any shapes that you want. I mean, you might have to Google the formulas for the volume of a cube or whatever. But once you have them, you can do that. And you can also extend the Cluedo version to add not just the name and the location, you can also include the weapon and get it to change weapons, same as we changed the location. Anybody got any questions about that before I leave that one? Have you been coding along, or have you just been staring at me? Good. I'm glad, Nikita. Everyone else is keeping quiet. Right, okay. If nobody has any questions about that, as I said, I'm going to do 2 this week. So we've done polymorphism. I'm also going to do inheritance, but I think you need a breather. So will we take 5 minutes and I'll see you back in 5?
Yeah, that's perfect.
Okay, see you in 5. Okay, that was weird. My camera and my microphone wouldn't turn on. And when I went to look at my task manager, something called Microsoft To Do was taking 60% of my CPU. Weird. Right, okay, we're finally back anyway, or at least I'm finally back. In that what felt like an incredibly short 5 minutes, did anybody have anything that occurred to them that they want to ask about before we move on? Okay, if there's nothing just now, then we will move on from polymorphism and jump straight in to inheritance. Excuse me. This is the second of the three big things that we're going to be looking at. So we've looked at polymorphism. We're just about to look at inheritance. And the other big one is something called encapsulation. The idea with inheritance is that if we are creating objects, there will be times when we are using some objects to describe other objects. If, for example, we are describing a car is made up of different objects. It's made up of engines and wheels and seats. But if we're describing a van, that's also made up of different engines and wheels and seats. Presumably the only difference is the type of engine, wheel or seat. So maybe what we can do is describe a vehicle and say things like, well, how many wheels does it have? How big are they? How many seats does it have? In other words, maybe instead of just taking each object as being its own standalone item, maybe we can be a bit smarter about it. Maybe we can, when we are designing our program, start to think about all the different things that are in there. And instead of reinventing the wheel, we can use some parts of the system in other parts. I'll show you what I mean. Maybe we want to define people, or an incredibly narrow definition of define. So as ever, we'll initialize our person. And we will pass it some very simple attributes. Our definition of a person is their first name and their last name. Clearly, there are a lot of other things that will define a person, but this is going to be enough for us to demonstrate how inheritance works. So we'll define a person just by their name, and we'll define a method that says, what you do for a particular person. And the show name is simply going to be a print first name, last name. Okay, so really simple. We can then define person, give them a first name, give them a last name, and then using that person, we can show their name. Okay, dead simple. While I'm running this, if anybody's got any questions about that, now would be the time to ask. Okay, it doesn't like being called inheritance, so we'll save it as INH1. And we'll try that again. It's not going well so far. What am I missing?
Brackets in the line 10.
One of these days I'll remember to use them. Okay, so we've got a very simple person, first name, last name, and we can print their name. And it's down here if you missed it. Now, there are some people, I'm not entirely sure I'm one of them, but some people would also say that students are people. Possibly still to be proven, but it's possible. If students are people, then presumably students also have the same sort of attributes as people and have the same sort of things that they can do. So if I am writing a system and I've already defined what a person is, and I now have to define what a student is, why would I start with a blank slate? Why wouldn't I say instead that my student actually doesn't start with no attributes at all? They instead inherit some attributes, and they'll inherit the attributes from people. So a student starts off being a person, and then we can add on some information. So again, we'll initialize the student. And you'll see there what VS Code has done for me. Because I've said that a student inherits the attributes from a person, when I've put in the init, it said, well, you're going to have at least the first name and the last name because that's what a person has. So if you're going to define a student as being a person, you're going to need at least the things that you would use to define a person. So it's very helpfully added them in for me. it's done something else, and this is the new bit that you won't have seen here. It's called super init. What it does, if you think about these objects as a tree, so we've got a person. In fact, give me a second here. Let me just do it this way instead. If we have objects, and we start off with our person, and we then define a student, that inherits all the attributes of a person. The student, its superior object, the one above it, is where we get that code from. If I go up to VS Code, all it's saying is the superior initialization, the one above it in the tree, doesn't mean better, it just means above. We're going to do this bit as well. So the first thing that we're going to do is initialize the person bit. So it's super class, it's the class that's above it. That's the first thing that we need to do. Initialize its superclass. And VS Code has added all that in for me to save me typing it in. Very kindly of it. But presumably we've created a new class because we want to add in more information. So the next thing that we're going to add to our init is simply to say self.university becomes university. In other words, we're saying the extra that we are adding in is the university name that the student goes to. So we can set up our new student, same as we did with our person. We can set up our student. And you can see there that it wants a first name and a last name and the university. So I can set up the first name. I can set up the last name. And I can set up the university. So you now have an object S1. Now, at the moment, student objects don't have any methods. They've just got an initialization. But because they're part of person, actually, student inherits all the methods from the class that we've set up. It's inherited all the methods from person. So I can say student show name. And I'll not forget the brackets this time. So when I run this, we get the same thing. So the method show name that isn't in student, but is in person, has been inherited because we've said that student is a type of person. So all the stuff that we set up here works its way down to here. Does that make sense? any methods that I define for the person will immediately be available to the student because they are a type of person. So you can see I set up a hello there in person. That's worked its way through to student. And when I said student, hello there, it said hello. So you can see that this is a powerful idea. We can set up base classes that take particular attributes, particular methods, and then extend them out. So you might want to say hello to a person, but not all people have a university. So to say welcome to the university wouldn't make sense for person, but it certainly makes sense for the student. So I can say, student, welcome. And we're happy with that. Welcome to UWS Isaac. But I can't do that with my person. Because welcome's not defined for a person. It's only defined for the student, and P1 is a person. So it's saying person has no attribute welcome, which means it doesn't have this method belonging to it. We're happy with that. Does anyone have any questions? Hopefully you're coding along as well. Okay, let's extend that out. So we can think about teams. Let's set up a class that's a team. And let's think about things that belong to teams all the time. It might have a name. That'll do for now. We'll just give our team a name. Dead simple. We probably want to, at some point, find out what that name is. So we'll define a new object. Yes, I apologize. We will define a new method called getName that's just going to return the name of your team. Dead simple. So in our code, we can say team 1 becomes team Aberdeen, print C1 dot get name. Okay, everyone happy with that? We've defined a name. One of these days, I will remember. Defined a team, given it a name, and we can go and get that name. And in this case, I've printed it off just to prove that we've set it up. Dead simple. But we've probably got different types of team. So I was thinking there of Aberdeen football team. But we might have team 2. Now, team 2, Glasgow Warriors, is a rugby team. So we're thinking about things here that are the same and are different. So let's think a wee bit about that. We might set up new classes called football, which are still teams. And VS Code is very kindly put in the setup there for me to say, okay, well, if football is a type of team and team has a name, then you will want to add in the name when you're setting up the football team. So again, let's think about what's similar and what's different. So teams play in a colour. Teams have strips and they play in a colour. So rugby teams do that, so do football teams. So actually the colour is probably part of the team. So we'll set that in the initialization for the team. We'll set up another method to get the colour. Okay. Aberdeen, plain red. And you can see here that it's now looking for strip colour because we've added in the strip colour into the team. Football is a type of team, so it realises we still need a strip colour here. So we can add that in. We can add in the colour red and we can get the colour. And we can do the same for a rugby team because it's also a team. They play in blue. So we can get our name and our colour for both our teams. Now, one of the things I want you to take note of here is the fact that when I changed that team and I added in the colour, I had to go back through and I had to do the initialization again and set it up with its new attributes. You don't want to be doing that every single time. I'm only doing that here to try and give you the idea of what you're needing to think about. The things that are the same, the things that are different. But you want to be thinking about those before you get anywhere near typing in the code. Imagine how tedious this is for something that has lots of attributes. And you just keep adding them one by one and updating all your code. A, you're going to get very annoyed. B, it's going to take you ages. And C, you're definitely going to miss something. So think very carefully about the things that are the same and the things that are different before you get to this point. So I'll leave that with that. I'll need to add in. Okay, so I'll leave that like that just now with a name and a strip color. But let's think about things that are different now. So football teams have a goalkeeper. So if we initialize a football team, we want a goalie. And we can say self dot goalie becomes goalie. Right. Football teams have a goalkeeper. But what if we are setting up a different team? Glasgow Warriors here aren't football. Oops. They are rugby. They're still teams. But when we set them up, we don't want a goalkeeper. And you see it's already taken strip and name from the team. But we want something else. We don't want a goalkeeper. We want a fly half. Because these different teams have different types of player. So now we can start setting up our teams. With our similar information, it's just a name. Actually, we can now say that this is football. And this is rugby. We've got similar things for getting the name, getting the colour, but we can define different attributes, different methods for the different types of team. So if it's a football team, we return the goalie. For the rugby team, So now we have similar things. You'll notice when I say T1 and hit dot, I've got the get color, I've got the get name, and I've got goalie name, but I don't have fly half name because we've set this up as a football team. So fly half doesn't count. The only thing we can get here is a goalie. And for this one that we've set up as a rugby team, and I ask it what it can do, it can get the colour, it can get the name, but it can't get the goalie name, it can only get the fly half name. So there are some things the same, the things that have been inherited, and there's some things that are different, things that are changing for the different type of see, and this is what happens when you forget to pass the stuff. I updated football and I forgot to add in the strip colour that we added later. So it got upset. And our super init is also wrong because it's not just the name, it's the strip colour. So you can see how irritating this becomes if we don't think it out beforehand. So this one worked. So we've got our football team working, but our rugby team stopped working. Why? Because we've got issues with the goalie name. And the fly half name, because we didn't do this at the start. So we're going to have to go through this code and fix it all. It's a right pain because we didn't do it all right at the start. But if I do this now for a new one and inherit the team stuff, very kindly sets it up exactly as I need for all of the things. And then I don't need to fiddle about with it. So get the main things right before you start doing the sub parts. If you don't, you're going to create yourself a huge amount of problems because you're going to be going back and changing things. And a lot of the presentation is exactly about that. It's saying, well, don't set up things where they are similar and reinvent the wheel, the strip colour, the name. Think about what's similar to begin with and set it up like that right from the beginning. Everyone happy with that? Does anyone have any questions about inheritance now?
Can we just go through another time about the purpose of the super function? Just to reiterate everything.
Yep, super is just saying, okay, you've defined a class. So in this case, hockey. But we're saying that hockey inherits all of the attributes from its superclass. So the one above it in its tree. So in this particular case, it would be the one that has inherited, oops, In this particular case, it's inheriting all the stuff from the team class are inherited by hockey. So we've got a tree here, and it just means super is saying the super class, the one that's above it. So team is above hockey because hockey is inheriting all the stuff, attributes, methods, everything that team has. It's the super class. So the code talks about the super in it. So if you define the class hockey, yes, you define hockey, but to do that, you also have to initialize the super class. So in this case, it's saying, okay, you've defined hockey as being of type team, as being a subclass of team. So the superclass also has to be initialized. In this case, the superclass is team, so you init that with the name and the strip color, same as we always have, the name and the strip color. But after that, we can start adding on extra things like goalies or whatever it happens to be. Is that okay?
Yep, it is.
Okay, so it's just, we have a tree of classes. We've only done 2, but actually there's nothing stopping us having more. So we could have a team and then we define a rugby team, but we could also define 15-a-side rugby or 7-a-side rugby. And they are both types of rugby team. So we have a superclass for 7s and 15s, and we have a superclass for rugby. So it can work its way all back into it. But the 15s still have a name, and they still have a colour, which are inherited all the way down from the team. As I said, we've kept it to 2 just for simplicity, but there's nothing stopping us adding more.
Mm-hmm. So just to recap, whenever we are trying to use a lot of classes in one, we have to write the super method.
Yeah, so VS Code adds it in for you, but it needs to be in there. And I think the other one also adds it in for you just to help, because it knows that there is a superclass.
Okay, perfect.
PyCharm also does it from memory.
Mm-hmm. Thank you.
Any other questions just now? Okay, that's getting on from noon. So if there's no other questions, we're going to have to leave that there. I hope that's helped. And if it hasn't, and there are other things that you want to ask, that's fine too. So put them into teams, put them into Teams as a question. I'm happy to answer them in there. Or come to the lab next week, and any code that you couldn't help, you couldn't work, we'll do it there. Howie, I'm happy to speak to you, but I have another meeting at 12. I'm sorry about that. Oh, actually, let me just stop the recording before I forget.